Have you ever stared up at the night sky and let your imagination run wild? You see the faint shimmer of distant stars, each one a sun, many with their own families of planets. We often picture these worlds as variations of what we know: rocky planets like Mars, gas giants like Jupiter. But what if the universe is more creative than that? What if, scattered among the billions of galaxies, there are worlds so strange, so alien, they defy our everyday experience? Could a planet made of pure solid diamond actually exist? Not as a fantasy, not as a metaphor for wealth, but as a real physical place you could, in theory, stand on: a world where mountains are carved from diamond. A world where valleys glitter with a crystalline sheen. It sounds like something ripped from the pages of a science fiction novel, doesn't it? A planet of unimaginable value, a treasure chest the size of a world. The idea itself challenges our Earth-centric perspective. Before we dismiss it as pure fantasy, let's do what science does best. Let's follow the evidence. Let me introduce you to a real celestial celebrity. Its name is 55 Cancri E. It's not a catchy name, I'll grant you that. It sounds more like a license plate than a world of wonder. But this planet, located about 41 light-years away in the constellation of Cancer, has captured the imagination of astronomers and dreamers alike. It's one of 5 known planets orbiting a star named 55 Cancri, a star you can actually see with the naked eye on a clear, dark night. This planet is what we call a super-Earth. That means it's rocky like our own planet, but significantly larger and more massive. Think of it as Earth's bigger, more extreme cousin. What makes 55 Cancri E so special isn't just its size, it's what it's made of. Early observations suggested something truly extraordinary. This planet orbits incredibly close to its parent star, completing a full year in less than 18 hours. Because it's so close, its surface is scorching hot, with temperatures likely soaring to over 4,000 degrees Fahrenheit, or about 2,200 degrees Celsius. But the real headline grabber is its composition. Based on its size, mass, and the chemistry of its host star, scientists have proposed a stunning hypothesis. A significant portion of this planet, perhaps as much as a third of its mass, could be pure diamond. Imagine that for a moment. A world where beneath a thick, steamy atmosphere, the ground itself is a vast, solid expanse of diamond. So how does the universe bake a diamond planet? The recipe is quite different from the one that made Earth. It all starts with the star. Compare sunlight composition to a carbon-rich star. Our sun is a typical star in its chemical makeup: oxygen, silicon, iron. As a result, planets that formed around it, including Earth, are silicate-based. Our crust and mantle are dominated by rocks made of silicon, oxygen, carbon. While essential for life, is a relatively minor ingredient in the planet's overall bulk composition. To build a diamond planet, start with a different stellar nursery, rich in carbon, poor in oxygen. In such a disk, chemistry is turned on its head. Instead of silicates, carbon compounds take center stage. Graphite, silicon carbide grains clump, grow, and accrete. Clumps collide and merge. Planetesimals, planets. Instead of a world with an iron core, silicate mantle, thin crust, you would get a planet with a core of iron, mantle of silicon carbide, thick crust of pure graphite, and that's where the magic happens. Add pressure to this massive carbon-rich planet. Immense, unimaginable pressure. On a super-Earth like 55 Cancri E, it has about 8 times Earth's mass. In a carbon super-Earth, graphite mantle becomes a planet-spanning diamond layer. Let's try to paint a picture of what it might be like to witness a world like 55 Cancri E up close. Forget any image you have of a glittering, perfectly cut gemstone floating in space. Reality would likely be far stranger and more awesome. From a distance, the planet might not look like a diamond at all. It's wrapped in a thick, soupy atmosphere. Given its extreme temperature and carbon-rich nature, this atmosphere could be a toxic brew of carbon monoxide, hydrogen cyanide, and other exotic gases, perhaps with clouds of graphite soot that would make the sky perpetually dark and hazy. You wouldn't see the sparkle from orbit. As you descend through this oppressive atmosphere, the pressure and temperature would climb at an alarming rate. The sky might shift from a dark gray to a hellish, glowing red as you get closer to the surface, heated to thousands of degrees by the nearby star. There would be no liquid water here, no gentle blue oceans. Any liquids on the surface might be bizarre seas of molten carbon compounds or other strange materials that can exist at such high temperatures. The landscape itself would be utterly alien, a scene of sublime and terrifying grandeur unlike anything in our solar system. This is not a welcoming place. And then, the ground. What would a surface of diamond actually look like on a planetary scale? It probably wouldn't be a smooth, polished facet. It would be a geological landscape. To truly grasp the alien nature of a diamond planet, compare it to the worlds we know best. Earth, Jupiter. Earth is our benchmark for a life-bearing rocky planet. It's defined by its abundance of liquid water, its nitrogen-oxygen atmosphere, and its silicate-based geology. Our planet is dynamic, plate tectonics, volcanoes, and active water cycle. It is a complex system of interconnected parts, oceans, atmosphere, land that work together to create a stable and habitable environment. Earth is a water world, a life world, a world of silicon and oxygen. A diamond planet like 55 Cancri E is the antithesis of Earth. Earth's geology =sign silicates. Diamond planet geology =sign carbon. Earth has vast oceans of water. 55 Cancri E might have oceans of molten carbon. Earth's atmosphere =sign life-sustaining blanket. 55 Cancri E's atmosphere =sign a crushing toxic furnace. Earth =sign hospitable to life. Diamond planet =sign extreme inhospitality, immense pressure and heat, ground made of diamond. This makes a diamond planet fundamentally different. The moment you hear diamond planet, your mind immediately jumps to one thought: wealth. An entire planet made of diamond. Surely that represents a treasure beyond all human comprehension. The idea of mining such a world is the ultimate fantasy of resource acquisition. A single trip could bring back enough diamond to forever alter our concepts of value and rarity. We could use it for everything from industrial applications, super strong cutting tools, durable coatings, advanced electronics, to creating jewelry for every person on Earth. The allure is undeniable. It's the ultimate cosmic gold rush. But let's ground ourselves in reality for a moment. The challenges of even reaching, let alone mining, a planet like 55 Cancri E are for now insurmountable. First, there's the distance. At 41 light-years away, even with our fastest current spacecraft, the journey would take hundreds of thousands of years. We would need a breakthrough in propulsion technology, warp drives, wormholes, or something we haven't even dreamed of yet, to make the trip within a human lifetime. The planet is a hellscape. The surface temperature is hot enough to melt lead, iron, and most other metals. The atmospheric pressure is likely dozens, if not hundreds of times greater than on Earth. Any probe, let alone a human crew, would be simultaneously crushed and incinerated the moment it entered the atmosphere. We would need to engineer machines from materials that can withstand these conditions, perhaps using the very diamond and carbide we seek to mine to build our equipment. It's a classic catch-22. The treasure is real, but the vault is locked. Let's allow ourselves to dream for a moment. Imagine a future where humanity has mastered interstellar travel. A robotic expedition, the Carbon Explorer, finally reaches the 55 Cancri system. Its mission: to land on the Diamond Planet. The lander, built from exotic alloys and shielded by layers of synthetic diamond, begins its descent. It plunges through the thick, sooty clouds, its sensors screaming as pressure and heat climb to terrifying levels. The view on its cameras is a swirling inferno of glowing red-black, a vision of a primordial underworld. The lander touches down, not with a soft thud but with a sharp, ringing clang as its legs make contact with the solid diamond crust. The first images are sent back across the light years. They show a landscape of dark, crystalline plains stretching to a hazy horizon broken by jagged peaks that glitter faintly in the dim starlight. A robotic arm extends, its drill, tipped with a laser of unimaginable power, whirring to life. It struggles to bite into the surface, the hardest material in the known universe. Slowly, painstakingly, it carves out a small core sample, a precious cylinder of alien diamond, filled with unknown impurities that tell the story of the planet's formation. In another, more distant future, perhaps humanity decides not to mine it, but to inhabit it. Not on the surface, of course. That remains a death zone. But what about in orbit? Imagine a grand orbital city, a ring station that floats high above the crush and heat of the atmosphere. The discovery of diamond planets, even as a theoretical possibility, does something wonderful for the human spirit. It shatters our planetary provincialism. For centuries, our understanding of planets was limited to the 8 worlds in our backyard. We had rocky planets, gas giants, ice giants. We thought we had a pretty good handle on the available models. But the cosmos, in its infinite creativity, has shown us that we were barely scratching the surface. Carbon planets represent a completely new category of world, born from a different chemistry, and they hint at even stranger worlds yet to be found. What else is out there? If a diamond planet can exist, what about a planetary ocean of liquid methane? What about a planet orbiting a pulsar, blasted by intense radiation with a vaporized metal atmosphere? What about a water world? one globe-spanning ocean thousands of kilometers deep. Each new exoplanet discovery adds another piece to the puzzle, revealing a far broader imagination than we do. The periodic table is a box of toys for the cosmos. It's using them to build everything imaginable. These exotic worlds force us to rethink our place in the universe. Earth is not the template. It is one of many outcomes. The existence of a diamond planet, hostile to life as we know it, underscores the preciousness and rarity of our home. We are a fortunate accident on a gentle oasis in a cosmos of beautiful monsters. So, the next time you gaze at the night sky, don't just see twinkling lights. See a gallery of possibilities. See a cosmic laboratory where nature is conducting experiments on a scale that dwarfs our comprehension. Up there in the darkness between the stars, are worlds of fire, worlds of ice, and yes, worlds of diamond. These discoveries are not just abstract data points on a chart. They are invitations. They are the universe beckoning to us, challenging us to be more curious, to ask bigger questions, and to never stop exploring. Like this page, follow our updates and become part of a group that believes in the power of science to inspire and unite. There's a whole universe out there waiting for us. So, as always, my friends, I urge you to do one simple thing: keep looking up.